So in last video we saw the what is energy density. In this video we will see what is electric dipole. So as you know, there is a charges will be there. So charge will produce electric field, right? So if there is a pair of charges, means the charge has a same magnitude, but it has the opposite signs in direction. So the opposite signs, and the charge has, if two charges are there together, which has one charge has plus charge, other one has minus charge, but the magnitude of the each charge is same. If you have 1 coulomb of charge plus charge, and similarly if you have minus 1 coulomb of charge, and if these two charges are separated by very small distance, very negligible distance, then that set of two charges is called as electric dipole. The electric dipole is a pair of charges with same magnitude and opposite sign separated by a small distance. So it is a pair of charges which has the same magnitude. If it is 1 coulomb of dipole, then it should have plus 1 coulomb and minus 1 coulomb, and it should be separated by very small distance. Then that set is called as electric dipole. Now if you see this diagram here, there are two charges at A and B, so which is separated by a distance called d. This d should be very small. Then this set of charges at A and B together is called as electric dipole. Now we will derive expression for electric field intensity due to electric dipole. So what is the electric field intensity produced from a electric dipole? Now I will consider a point P, so which is represented in a spherical coordinate system with r, theta, phi as its spherical coordinates. So this point P, which is at a distance of r from the origin, which is at a distance of r from the origin. Now I am placing a charge plus q at A and minus q at B. So I am placing at A and B a electric dipole. I am placing an electric dipole at point A and point B. So distance between point A and point B is considered as D. The distance between point A and point B is considered as D. Now the distance from the positive charge, that is plus q, that is placed at A, from A to P is R1. The distance between A to P is considered as R1. Similarly, distance from B to P considered as R2. Now, what is the expression for potential at P due to A and due to B? What is the potential expression for V, that is at P due to A and B? So, which is written as V1, that is a potential due to P due to A, is given as plus Q, that is a charge at Q, that charge at A, that is plus Q divided by 4 pi epsilon naught into the distance between A and P is R1. So V1 is equal to plus Q divided by 4 pi epsilon naught into R1. So this is the potential at P due to A. Similarly, what is the potential at P due to B? So what is the distance between B and P is R2. What is the charge at B is minus Q. So V2 can be written as minus Q divided by 4 pi epsilon naught into R2. So V2 can be written as minus Q divided by 4 pi epsilon naught into R2. It is the potential at P due to B. Now what is the total potential at P? So it is a sum of potential due to A and potential due to B. So that is V1 plus V2. So V is equal to V1 plus V2. So if you add, you will get V is equal to plus Q divided by 4 pi epsilon naught into R1 minus Q divided by 4 pi epsilon naught into R2. So if you take Q outside, you will get Q by 4 pi epsilon naught into 1 by R1 minus 1 by R2. If you further simplify this, you will get Q by 4 pi epsilon naught into R2 minus R1 divided by R1 R2. So if you take LCM and multiply, you will get R2 minus R1 divided by R1 into R2. This expression will become Q by 4 pi epsilon naught into R2 into R2 minus R1 divided by R1 R2. So I'll take this as equation 1. Now if you go to previous this diagram, if this distance R1 and R2 is equal, if you this distance R1 and R2 are equal, now what is the potential at that particular point P? So potential at that particular point will be equal to 0, right? So because when R2 is equal to R1, this expression will become 0. So potential at the point P will be equal to 0. Now, so this is the case when the potential at when the points lies with the equidistance from both the charges of dipole, that is point A and point B. Then the potential at point P will be equal to 0. Now I will consider other case where this point P lies far away from point A and B. So this P will lies very far away from point A and point B. That is, we will consider the distance between A and P is nearly equal to infinity. If the distance is infinity, if the distance is very large, then these three lines, that is the line joining A and P, the line joining origin and P, and the line joining B and P is considered as, will be considered as parallel, because it is almost looks like a parallel. If the line length is very large, then this will almost looks like a parallel at this position. At this position it will look like a parallel lines. At the infinite position it will join, but at the starting of these lines at A, O, B, these lines will looks like a parallel line. So R1 will be parallel to R2, will be parallel to R2. So if P is in infinite, right? Now to find what is the expression for electric field intensity, I'll make some arrangement here. I'll draw a perpendicular line from point A to the line joining B and P, that is R2. So I'll draw a perpendicular line from point A to the line R2. I'll take the line joining that perpendicular line, and the R2 is taken as M. The angle made by this line joining from B to P is taken as theta. B to P is taken as theta. So how we can write this AM? What is the distance between A and B? A and B distance is D. A and B distance is D. Now how I can write what is the relation between this AB and BM? What is the relation between AB and BM? How we can write? If I redraw, take this triangle outside and redraw it, it will look like this, right? It will look like this. So it is A, B, P. So this is a point A and this is point B and M, point M. So this is the angle theta. So this is the distance between A and B is D. Now how we can write this BM line? So what is the relation between BM and AB and theta? So I can write BM is equal to AB into cos theta. This is a hypotenuse line and this is adjacent line. So adjacent by hypotenuse will be the equal to cos theta. So BM is equal to AB into cos theta, or cos theta is equal to BM by AB. So I can write BM is equal to AB into cos theta. What is AB? AB is this distance, that is D. So I can write D BM, which is equal to D into cos theta. So BM is equal to D into cos theta. Now what is this line? This line is the line joining between point P and point B. So I can write PB. So PB can be written as this length line, that is BM, plus what is the remaining line, that is MP. So PM plus BM, which is equal to PB. So what is PB? PB is R2. So what is BM? BM is D cos theta. So I can write, so PB is equal to PM plus BM. So here, if you consider this as perpendicular line, then I can write PA, which is equal to PM. So PA, the line joining from here to P is PA, so which is equal to PM. So I can write PA is equal to PM. but PA is R2, and so I can write PA is equal to PM, which is equal to R1. So PA is equal to R1. So PA equal to PM equal to R1. And we know that what is PB? PB is R2. So substituting all the values, you will get BM is equal to PB minus PM. So we know that PB is R2 and PM. So we will keep it as it is and substitute PM as R1. We will get BM is equal to R2 minus R1. So what is BM? So according to this equation, BM is equal to d cos theta. So substitute that. So you will get d cos theta, which is equal to R2 minus R1. So d cos theta, which is equal to R2 minus R1. Here we taken PA is equal to PM because we have joined a perpendicular line. So if the lines are parallel, then the length of AP and length of MP should be equal. So we have taken PA is equal to PM, but PA is equal to R1 and PB is equal to R2. So if you take here, in this, if you write BM is equal to PB minus PM, you know that PB is equal to R2 and PM is R1. Substituting that, BM is equal to R2 minus R1, you will get. So what is BM? BM is d cos theta. So d cos theta is equal to R2 minus R1. So you will get d cos theta is equal to R2 minus R1. So if this d as the definition of the electric dipole, we have to consider the distance between the two charges are very small. So d should be very small. Then if the d is very small, if this distance is very small, I can take R1 which is equal to R which is equal to R2. So if the distance between these 3 points are very small, then I can take R1 is equal to R which is equal to R2. So I can write R1 which is equal to R2 which is equal to R. I can write R1 into R2 which is equal to R square. So I will substitute R2 minus R1 which is equal to d cos theta and R1 into R2 which is equal to R square in the equation 1. I will substitute in this equation R2 minus R1 as d cos theta and R1 and R2 as R square. So I will get V is equal to Q by 4 pi epsilon naught. Instead of R2 minus R1 I have substituted d cos theta and instead of R1 R2 I have substituted R square. So I will get V is equal to Q by 4 pi epsilon naught into d cos theta R square. But we know that the equation for potential gradient is E is equal to minus del V. So what is del V? Del V is dou V by dou R into AR cap plus dou 1 by R into, this is the equation for del V. So E is equal to minus del V. So what is V? We know. So differentiating with respect to R, theta and d phi, you will get. So dou V by dr is equal to minus 2q d cos theta divided by 4 pi epsilon naught into r cube. So in the place of V, substitute this and differentiate with respect to R, you will get this equation. Similarly, so in the place of V, substitute and differentiate with respect to theta, you will get dou V by dou theta as this equation. Similarly, you will get dou V by dou phi as 0 because phi component is 0 in this equation. So you will get dou V by dou phi as 0. So substituting all the terms, that is dou V by dou R, dou V by dou theta and dou V by dou phi in the previous equation, you will get in equation 2, you will get E is equal to minus 2q d cos theta divided by 4 pi epsilon naught r cube into AR cap minus qd sin theta divided by 4 pi epsilon naught r cube A theta cap. So simplifying this, and you can get expression for E as this. So this is the expression for electric field intensity due to electric dipole. So in next video we will see some problems on the energy density, and this will be the end of the first part of the second module. Thank you.